Hey everyone, welcome back. This is section 11.4. Today we're talking about corresponding parts of similar triangles. We're going to start with the proportional parts conjecture, and it states that if two triangles are similar, then the lengths of the corresponding altitudes, medians, and angle bisectors are proportional to the lengths of the corresponding sides. So this conjecture kind of expands our understanding of similar triangles. Not only do corresponding sides relate to each other proportionally, but now we also know that these other parts of triangles, altitudes, medians, and angle bisectors, will be proportional. We're going to take another look at the angle bisector. Recall when you first saw an angle bisector in a triangle? You may have thought that the bisector of an angle in a triangle divides the opposite side into two equal parts as well. A counterexample shows that this is not necessarily true. In triangle ROE on the left, RT bisects angle R. We can see this by the tick marks. But point T does not bisect side OE, right here. We can clearly see that the length of side OT is not the same as the length of side TE. They are not congruent. If we look at the triangle on the right, we have a median, RM. Now we know a median bisects the opposite side, and we can see this by the tick marks. OM is congruent to ME. However, this median does not bisect angle R. We can clearly see that the two angles here have different measures. So the angle bisector does not bisect the opposite side. However, it does divide the opposite side in a particular way. The angle bisector opposite side conjecture explains how the angle bisector bisects that opposite side. It states, a bisector of an angle in a triangle divides the opposite side into two segments whose lengths are in the same ratio as the lengths of the two sides forming the angle. Let's use this new conjecture in this example. Here they ask us to find V. Well, you can see that V is the length of that segment. By the tick marks that we see here, we see an angle bisector. Now the two sides, 45 and 20, will create the ratio that splits the opposite side. So 45 over 20 has to equal the ratio of the two segments that make up the opposite side. In this case, 36 over V. Now we have a proportion that we can cross multiply and solve. 45V equals 720. Divide both sides by 45, and we get V to equal 16.